Welcome to lesson 4 and 5 in the matrices topic. These lessons cover scalar multiplication. So in your workbook, I want you to write down this heading, multiplying a matrix by a scalar, and we're going to put in a couple of definitions. First is that a scalar multiplication is the process of multiplying each element in the matrix by a number. And I've put in bracket there, a scalar. So I think it's best explained by the following example, which I've got in point 2. So I want you to write down in your workbook that this is an example of scalar multiplication of a matrix. So here we've got the example where the scalar is the number 5, and the number 5 is being placed in front of a 2 by 2 matrix that you can see there, 1, 2, 2, 0. And in the middle, as we work across, you can see that the 5 has been taken in and multiplied by each of those 4 elements inside the matrix brackets. And then finally, at the end on the right there, we've consolidated with what is a result of each of those multiplications. 5 by 1 becoming 5, 5 by 2 is 10, 5 by 2 is 10 again, and then 5 by 0 is 0. So it's really the process of taking a number or a scalar inside the matrix and multiplying each element. So once you've finished getting those definitions down from the previous slide, let's have a look at this first worked example. And here I've given a matrix called A, and it's defined as a 2 by 2 matrix with the elements 5, 1, -3 and 0. And the questions ask us to find 3A. And remember, there's a little multiplication sign, just as we know in algebra, between the 3 and that letter A. So the first thing we want to do, first step if you like, is written down there on step 1 that A, obviously a matrix. When we have 3A, we're replacing a 3 in front of the 2 by 2 matrix, as you can see there under step 1. Taking it across to the right in blue, we've just done exactly that, no real change. Step 2 is where we start to bring that scalar number 3 inside the matrix. Like we saw on the previous slide, every element inside that 2 by 2 matrix is being multiplied by 3. So we have 3 by 5, then we have 3 by 1, we have 3 by -3, and finally 3 by 0. And the final step 3, is evaluating each of those calculations. So obviously the 3 by 5 becomes 15, 3 by 1 is 3, 3 by -3 is -9, and 3 by 0 is 0. So just make sure you get that down in your book before you click on to the next slide. Let's have a look at our second worked example. This one, we've got a matrix capital C, which is shown there to a 2 by 3 order matrix. We've been asked to find the -6C, which effectively is we're wanting to multiply every element by the number -6 as a scalar. And that's what we've written exactly here in this first line, where we've placed -6 out the front and timesing it by each of those elements in the matrix. So what we do in the second line is we take that scalar or number -6 inside and we write it out longhand, multiplying each of those elements. And you'll see for the first one, it's -6 times 3, moving across on the top line, -6 times -4, and so on. And then finally, what we're doing is it's just a case of, for each of those expressions, simplifying them down to what they equal. So -6 times 3 gives us -18. And the next one across the top, the -6 times -4 gives us a positive 24, and so on. And the important thing here is we need to be very careful of our positive and negative signs. So being aware that a negative and a positive gives us a negative, but 2 negatives obviously give us a positive. So just be aware that when you are multiplying by a negative scalar, you're taking that inside the matrix, just as has been done here. So now I'd like you to have a go at your turn of doing a scalar multiplication. And here we've been given two 2x2 order matrices, one defined there for A and one defined for B. We've been asked to find 2A and 3B, and then find the solution to 2A minus 3B. So it's sort of stepping it through slowly. So before you go on to I show the solution, you might like to pause the slide here and try it yourself, and then you can check. If you're a bit stuck or don't know where to get started, then perhaps continue on following the solution. So the very first thing I've put up here is 2A. What does that mean? We're multiplying 2 as the scalar by everything inside the matrix A. So that's how I've written it there. 2 multiplied by the matrix A that was defined above. And then we've let that equal to what the result of taking that 2 inside and multiplying on every element. So I've missed the step that we saw in the last slide where I explicitly wrote 2 times 1, 2 times 1, 2 times 0, and so on, just as a way of moving it along. If you do need to do it longhand like before, then you're welcome to do, and if that helps you, until you get to the point that you can do it as shown just here. So now we want to work out 3b. What does that mean? It simply means 3 as a scalar times by the matrix B. So again, we've written 3 times and replaced B with the matrix B there, and worked out the result from 3 times every element in the matrix. So now once we've got that, we've effectively got the 2 elements of this calculation. We want to work out 2a minus 3b. So I've simply, on the final line, replaced 2a with what we found out by calculating 2a, also replaced 3b from what we found out by working out 3b. And then it's a simple use of the addition or subtraction rules that we saw in the earlier lesson, where we need to deal with each respective corresponding element in the matrix. So the 2 needs to be lined up with the 0 for the top left or row 1, column 1. So we've got 2 minus 0. And then we work our way through the rest of the matrix by 2 minus 3, 0 minus 3, and 2 minus 0. And then the final bit there on the right is the result of those calculations. So we just need to simplify or consolidate, and that's our final result of 2a minus 3b. So just a final opportunity to have a go at applying scalar multiplication. This one more in a worded sense, but we've still got a matrix, and what it says is a gymnasium has enrollments in a course that are shown in this matrix. So down the left hand side we've got rows of relating to men and women, and then across the top that's divided into bodybuilding, aerobics and fitness. So for instance, if we were looking at how many women were doing aerobics, we can go to that second row, second column, we see there's 50 women who do aerobics. So the condensed way of giving us information, what we want to know, the manager wishes to double the enrollments in each course. So how would we go about this in a matrix? Nothing more complicated or needing any more thinking other than we want to use a scalar. We're doubling, we're going to use a scalar of 2. So we effectively want to multiply with a scalar of 2 this entire matrix. So you can have a go and pause the video here, or you can, once you've done that, continue on and see how it's been done on the right hand side. So like I said, we want to multiply each element in the matrix by 2, and that's what we've done in blue there on the right. Put a 2 multiplied by the matrix which we have. This has been done the longhand way we saw earlier, where the 2 has gone in and operates on every element. So the first element, it's 2 times 70, and so on for the other 5 elements. And then the final answer is simply consolidating those calculations. So 2 times 70 for the first one becomes 140. And we present it with the titles along the top for the columns and a title down the left-hand side for the rows. So that's I guess, a more of a practical application or worded practical application where we might use a scalar multiplication. Thanks for watching.